equation. It is Riccati So we are talking about Riccati's differential equation. So what is a Riccati's differential equation? So the nonlinear equation, the nonlinear differential equation of the form dy by dx equal to p of x plus q of x times y plus r of x times y square is known as Riccati's equation, Riccati's equation, right? Some of the things that I want to talk about, it is first order, and is it linear? So the answer is no, not linear, which is obviously written over here. It is non-linear. Fine, so not linear, obviously. How about its degree? So you need to find out what is its degree. So degree is the power of the highest derivative, so it is going to be 1, obviously. So how are we going to solve it? So obviously we will adopt the common methodology that is used to solve this, and for this we assume first, so how to solve. So solution of such kind of equation involves these steps. First is to assume y1 to be a particular solution. So you need to have, one particular solution. So I am kind of giving this equation 1. So it is a solution, particular solution to equation 1, obviously, right? Now what I have to do is I will define some transformation. So I will define, in other words, change of variables, which is the u, and this u is a new variable. So my task is going to be to transform the original differential equation into another differential equation in the variable y. So for this I will define this. So I will set this y equal to u plus y1. So y1 is assumed to be the solution. Now because y1 is solution, so we need to keep in head that by default this is true, dy1 by dx. So first derivative of y1 equals p of x plus q of x times y1 plus r of x, and then multiplied by y1 square, right? So this is by default true because we will use this, so that's why I'm writing it, right? Okay, so because we want to transform the equation 1 into variable u, so we need what? So we need dy by dx in terms of du by dx. So let's do that. So derivative of y with respect to x is equal to derivative of u with respect to x plus derivative of y1 with respect to x. So we can change the equation 1 into u by using these transformations. Now equation 1 will imply this. It is going to be what? So my equation 1 is equal to this dy by, so derivative of y with respect to x equals to p of x plus q of x times y plus r of x times y squared, right? So where p, q and r are functions of x. Now this will be replaced by du by dx. So derivative of u with respect to x, derivative of y1 with respect to x equal to p of x plus q of x times, now this y is u plus y1, and r of x times, so it is u plus y1 squared. So when you simplify, you will get this is the derivative of u plus this is the derivative of y1 equals to p of x plus q of x times u plus q of x times y1 plus r of x times u squared plus 2u y1 plus y1 squared, and this bracket closed. So from here I get what? I get this guy. So I get du by derivative of u with respect to x. So when I say du by dx, I mean derivative of u with respect to x plus derivative of y1 with respect to x equal to p of x plus q of x times u plus q of x times y1 and plus r of x times u squared plus 2 times u r of x y1 plus r of x multiplied by y1 squared, right? Which can again, can be written as du by dx plus dy, also so derivative of y1 with respect to x minus this p of x, and then I will take this term on the left side, which is q of x y1, and this term minus r of x and y1 squared equals to, so what are the terms which are left? This term is left, this term is left, and this term is left. So we are left with q of x with u plus r of x with u squared plus 2 times u r of x and y1, right? Now you can see this from here that because y1 satisfies the equation in the sense of particular solution, so from there I can say that this guy is 0. So it follows from this. So you throw this p of x, q of x, y, r of x times y1 square on the left side, so this side is equals to 0, and that's why that goes to 0. So we are left with what? We are left with this quantity. Now I'll write here. So we are left with the derivative of u with respect to x to be equals to 2 times of u times y1 and r of x plus u squared r of x and plus q of x times u. So this term contains u plus this term contains u, so I can combine them together to write the derivative of u with respect to x to be equals to 2y1 r of x plus q of x times u plus r of x times u squared, which can be written in this form, that derivative of u with respect to x minus q of x plus 2y1 r of x times u equals to r of x u squared, right? So now you can see this equation is the particular Bernoulli equation for n equals to 1. So recall what is the Bernoulli equation. So let me write what do we mean by Bernoulli equation. So Bernoulli equation is always of this form. So it is some variable, maybe y by dx plus p of x times y equals to some function, maybe q of x. Okay, so I should change this q of x times y power n. So if you keep p of x as this function with minus sign, and q of x this r of x, and n equals to 2. So this is Bernoulli equation with n equals to 2. So this is Bernoulli equation with n equals to 2. So we already know how to solve or how to tackle the Bernoulli equation. If you don't know, you must know it first, So this equation that we are left with is derivative of u with respect to x minus q plus 2y1 r of x times u equals to r of x u squared, right? And in the case of Bernoulli equation, the supposition that we take is u equal to so like in this case, because we have already used w, so I will take another variable which is w, which should be y power 1 minus n, but in our case n is 2, so w should be y power 1 minus 2, which is y power minus 1. So the supposition for this, in order to apply the method that we apply to Bernoulli equation, we must take this w to be u power 1 minus n, which is actually 1 minus 2, or you can say u power minus 1. But now my task will be to convert this Bernoulli equation into w, from u to w, and you will see that this is going to be a linear differential equation. So for this we need to take the derivative of w. It is going to be, by chain rule, this quantity. From here I can take the value of u with respect to x, derivative with respect to x, as it is going to be minus u square times derivative of w with respect to x. Now you just change this derivative of u into this w in the equation number 2. So this is my equation 2. So my equation 2 will be so it is going to be minus u square derivative of w with respect to x minus q plus 2y1 r of x times u equals to r of x times u square. But I can multiply all of this equation with, or divide all of this equation by minus u square. So when you divide all of this with minus u square, this will get cancelled with this, and this will get cancelled with this. So we are left with the derivative of w with respect to x. So this minus and minus is going to be plus q plus, so this q is a function of x, you must know this, 2y r, so r is also a function of x, u power minus 1 by simplifying equals to r of x, but with this minus sign. And you can see that this is linear differential equation which can be solved by integrating factor. So what is going to be integrating factor in this case? So we will define that integrating factor maybe with z. So z is going to be the integral e to the q plus 2y1 r and dx. So you must know that this q and r are the functions of x. So when you will apply this, so now this is linear equation which can be solved with integrating factor. Now we will solve an example. So we have got this Riccati's equation. Now we will solve this Riccati's equation because method has been discussed. So I can write this in this form: dy by also the derivative of y with respect to x equal to 2 minus plus 2x times y plus 1 times y square. So just to let you know that this is my p of x this is my q of x and this is my r of x. One thing that you must keep in head is one particular solution must be either it should be given, or you need to apply some suitable method that you must know from the differential equations to find out the particular solution. Once you have the particular solution, then you can proceed with the general solution towards the general solution. So this should either be given, or you need to know, you need to know some methods through which one particular solution can be found out, right? So in this case, y1 equal to 2x is the particular solution which is given. So now my task is to define a new variable where I'll transform this equation. So my new variable is u, which is y1. So my new variable is u, and my transformation takes this form, y equal to u plus y1, or one can say that y equal to u plus 2x. Now take the derivative of y with respect to x. It is equal to the derivative of u with respect to x plus 2. So now what we will do is we will take this value plus this, I'll substitute in the equation 1. So my equation 1 after on substitution gives me 1 implies that so this dy by dx is equal to, so equation is 2 minus 2xy plus y square. So you can just substitute the values, derivative of u with respect to x plus 2 equal to 2 minus 2xy plus y square, but these y's must be taken into u, so I'll substitute these values here. It is u plus 2x. It is u plus 2x. This 2 gets cancelled with this. So this will give me the derivative of u with respect to x equals to 2xu minus 4x squared plus u plus 2. Oh sorry, this was a square, this is a square. So this must be, this is a square, so u square plus 4xu plus x squared, right? So from here what we get, the derivative of u with respect to x to be equals to minus 2xu minus 4x squared plus u squared plus 4xu plus x squared. So we are making a mistake. When squaring this, there will be 4x square. So here we will also have 4x square. So this minus 4x square, this plus 4x square will get cancelled, and what we are left with is the derivative of u with respect to x to be equals to 2xu plus u squared plus 4 times xu. But now these two can be simplified further to get the derivative of u with respect to x. So it is going to be minus 2xu equals to u squared. Now this equation is the Bernoulli equation with n equals to 2. So I'll bring another variable change, and now I'll define w equal to u power 1 minus n, so which is u power 1 minus 2, which is u power minus 1, and my derivative of w is going to be minus u times minus 2, the derivative of u with respect to x. So from here, let this, and from here the derivative of u with respect to x takes this form. So rearrange this with your simple algebra, right? Now I'll substitute this value of derivative of u over here. So this is equation 2. So my equation 2 will take what form? equation 2 implies. So equation 2 is this. Equation 2 is going to be minus u square, the derivative of w, minus 2xu equals to u squared. And when you divide this equation, minus u square with minus u square, what we get here, we get these cancelled, and we are left with what? The derivative of w with respect to x, so plus 2xu power minus 1 equals to minus 1. But this u power minus 1 is w, right? Okay, so when I was defining this generally, this one was w, right? Because in the substitution we took this one over here, so that's here, right? Okay, so what I will write now, I'll write the derivative of w with respect to x minus 2x w equals to minus 1, because this u power minus 1 over here is equals to this w, right? So now we are left with an equation which is linear equation, and its integrating factor, which I will write as z, it is e to the integral of minus 2x dx, which is e to the minus 2 x squared by 2, so it is e to the minus x squared. So let's multiply this equation with, this integrating factor. So this is equation 3. My equation 3 now will be this. Right, so this is derivative of w with e to the minus x squared, right, and equals to minus e to the minus x squared. So this implies w times e to the x squared with differential minus e to the minus x squared dx. Once you take the integral, what we get here is w times e to the minus x squared equals to minus integral of minus x squared dx. But you know that this integral cannot be kept in the elementary functions, so I will take limit x naught to x, and I'll change this variable to t. So I write this w times e to the minus x squared is equals to minus times x naught to x t squared dt. Now let's substitute back everything that we have. So the w was equal to u power minus 1. So I'll take u power minus 1 because w was taken u power minus 1. X squared equals to, so I'm substituting back whatever we had substituted in the start. Right, but from here I can write by 1 upon u into e power minus x squared equals to minus times integral from x naught to x e to the minus t squared dt. Right. But now, what was u in terms of y in the start? So we took this y equals to this, so this u must be y minus 2x, right? So I will put this y minus 2x in place of u. So y minus, so it will give me 1 upon y minus 2x e to the minus x squared equals to minus integral x naught to x e to the minus t squared dt, right? Now I have to separate this y. While integrating, we forgot to put the constant value c here, so this c is here, this c must be here, because when we integrated on this side, at least we have integrated fully, so we need to have a constant plus c, right? So I can write this equation in this form: c minus x naught to x e to the minus t squared dt equals to y minus 2x, but that can be written as y of x equals to 2x plus e to the minus x squared divided by c minus x naught to x e to the minus t squared dt. So that's the solution to that Riccati's equation.